Welcome everybody to the 6.1 video, Properties of Exponents. My essential question for today's video, which is actually going to be the same essential question for the next few videos, is right here, how can you write general rules involving properties of exponents? In total, I have 7 different properties. In this particular video, I will be learning 2 of them. They are my learning objectives. So my first learning objective is to learn and understand the product of powers property, and my second learning objective is to learn and understand the quotient of powers property. So we're going to work with them one at a time, and we will look at examples, follow through with some formal definitions, and then take a look at some practice problems. My learning objective 1 here is again based on the product of powers property, and what I'd first like to do is fill out this chart before we actually get into exactly how the power of product property works. So if we look at the first line, which is done for us, I have first 2 squared. So that is going to tell me 2 times itself twice, and here's that once and twice. I'm multiplying that by 2 to the 4th. That's here. So that means 2 times itself 4 times. And I have that 1, 2, 3, 4 times there. Okay. So if I look at these all together, I really have 2 times itself 1, 2, 3, 4, 5, 6 times. And that's where I get this answer here, 2 to the 6th. If we fill out this second one, the second line, my first power is 5 cubed. So that's going to be 5 times itself, 5 times, and I'm multiplying that by 5 squared, which is 5 times itself twice. And so altogether, if I count them, I get 1, 2, 3, 4, 5. That is 5 to the 5th power. What I'd like you to do at this point is go ahead and pause the video, fill out the last 2 lines on your own, and then when you're ready, you can resume it, and we can go ahead and figure out what these last 2 lines are. All right, hopefully you are done with the 2 lines and you've unpaused the video. Working on the third line, I first have x to the 4th, so that's x times x times x times x. And I am multiplying that by x to the 7th. So that's x times x times x times x times x times x times x. If I count up all my x's, I will find that I have x to the 11th power. Working on the 4th line here, my first power is a to the 6th. So that's a times a times a times a times a times a, and then I'm multiplying all of that by a squared, which is a times a, and if I count them all up, I find that I get a to the 8th power, just by counting up all my a's that I have there. What I also want you to notice, okay, is that in the powers up here, 2 and 4, if I add those together, I get this 6. The same thing with the second line. I have 3 and 2. If I add 3 plus 2 together, look what happens. I get 5. If I add 4 and 7, I get 11. And the same thing here with 6 and 2. I get 8. Based on that pattern, okay, we can derive the power of a product property. And what the power of a product property looks like notationally would be in this box here. A to the m times a to the n equals a to the m plus n. So in other words, if we are multiplying two powers with the same base, which is very important that they have the same base, okay, we add the exponents. Okay. And notice that all of these in the examples, my base here, 2. My base here, 5. My base is here, x. My base is here, a. All of my bases are the same, so when I'm multiplying two powers with the same base, I go ahead and I add my exponents together. And that is product of powers property. Moving on to objective 2, power of quotients property. I have a similar chart here, and again, the first one is done for me. So if I look at the first line, the first power that I have is 2 to the 5th. And that gives me 2 times 2 times 2 times 2 times 2 up here. 2 times itself 5 times. Then in the denominator, I have 2 squared, and that's down here, 2 times itself twice. Once I get to this point, I can cross out 2's that cancel on the top and bottom, and that's what happens here. If I cross out 1 on top, I can cross out 1 in the denominator. If I can cross out another in the numerator, I cross out another in the denominator. And what I'm left with is just this piece right here, which is 2 times itself 3 times, which means I can write it as 2 cubed. Whoops. So if we go ahead, let's do the second one again, together as well. I first have 5 to the 8th. So that's going to be 5 times itself 8 times. 2, 3, 4, 5, 6, 7, 8. I'm going to put that all over 5 to the 6th. So 5 times itself 6 times. 3, 4, 5, 6. And then I'm going to cancel out the 5's in the numerator and the denominator. So 1 on top, 1 on bottom, 1 on top, 1 on bottom, 1 on top, 1 on bottom. I keep going until however many there are cancels. And now I see that all that I'm left with is this right here. 5 times itself twice. My base is 5. My exponent is 2. So 5 squared. At this time, I would also like you to pause the video, fill out the last 2 lines, and when you're ready, come back and we'll figure out if you got them right or not. Hopefully at this time you have unpaused the video, you've completed the last 2 lines on your own. Let's see how you did. For the third line, in my numerator, I have a cubed, so that's a times itself 3 times. And I'm putting that all over a to the first. So that is just 1a in the bottom, denominator. And then cancel 1 on top, cancel 1 on bottom. That's all that's going to cancel. And what I'm left with is a times a. So I can write that as a squared. Working on the last line, first I have x to the 7th. So I have x times x times x times x times x times x, and one more, all over x cubed in the denominator. So x times itself 3 times. And then I'm going to cancel what I can. And what I'm left with is x times itself 4 times. So that's going to leave me with x to the 4th. If we're looking for a pattern here again, okay, I'm going to erase that so it's just a little clearer. Here, my bases are 2's. Here, I have a base of 5. Here, I have a base of a. And here, I have a base of x. Again, all of my bases are the same in the numerator and the denominator. When that happens, if I look at my exponents, 5 and 2, well, if I subtract 5 minus 2, I get 3. And that's what I get over here, too, when I rewrite each power as a single power. Here I have 8 and 6. 8 minus 6 gives me 2. 3 and 1. 3 minus 1 gives me 2. And then 7 and 3. 7 minus 3 gives me 4. Based on the pattern that we see in the chart here, I can derive the power of quotients property. And notationally, that's going to look like a to the mth power all over a to the nth power is equal to a to the m minus n power. And so in words, the way that I can write this is that when two powers are being divided, but with the same base, again, very important that the bases are the same. Okay. We can subtract the exponents. And that's exactly what we did. All of my bases were the same. So as I showed you before, we subtracted our exponents and it left us with these exponents here. We just did it more mathematically and figured out why that happens in the chart. So those are the two properties of exponents that we're learning in this video. Here are 4 examples that we can work through together. This first example here works off the product of powers. Okay. When I am multiplying 2 powers with the same base, I add the exponent. So my base here in both powers, x squared and x cubed, is going to be x. So I'm going to add my exponents. I get 2 plus 5, which equals 7. So my final answer is x to the 7. I keep my base and I give it a new exponent. This question here is also product of powers. Just doing it in a different color so that you can see it a little bit clearer. My bases are the same in both. It's 3. And so I'm adding my exponents, which are 11 plus 5, which equals 16. So my final answer is 3 to the 16th power. When I move on to number 3, this is going to be quotient of powers because it's division. My bases are the same in both the numerator and the denominator. I have a. And so I'm going to subtract my exponents. And I will be doing 12 minus 4, which equals 8. So I keep my base. Let me try that again. I keep my base, which is a, and I add my new exponent, which is 8, a to the 8th. And finally, I have 6 cubed over 6. This is, again, quotient of powers. In both my numerator and my denominator, my base is the same. It is 6. And so I'm going to subtract my exponents. This one is a little bit different or tricky, but it's not too bad. In my numerator, my exponent is 3. And I'm subtracting, well, what's my exponent in the denominator? I just have a 6. So when there's no number there, like usual, even though I don't see it, I should know that my number is 1. So I'm really doing 3 minus 1. 6 to the first power equals 6. And that will give me 2. So my final answer is 6 squared, keeping the base, tacking on the new exponent. Please do not forget to bring this note packet in tomorrow. I will be checking it and putting it in as a grade. And also, please do not forget to complete the Google form.